Hi everybody, in this video let's try some question from your Form 4 and Math Chapter 5 progression. This question is taken from SPM 2022 Paper 1 Section A, Question 12. Diagram 8 shows a purple color right angle triangle patterns on the net of a rectangular roll of paper. It is given that the length of the base, which means here, of the first triangle is A centimeter, this is A centimeter, and the length of each subsequent base increases by d centimeter. So this is A, here will be A plus d centimeter, and this one will be A plus d will be A plus 2d centimeter, and so on. So this is actually an arithmetic progression. Part A, we want to derive that the length of the base of the n triangle is this Tn is equal to A plus n minus 1d. So I think majority of students still know about this formula, right? This is a Tn, the formula for Tn for an arithmetic progression. But now the question asks you to derive this formula. Okay, now T1 is A, right? So T2 is equal to A plus d. T3 is equal to A plus d will be 2d, A plus 2d. T4, A plus 3d. Okay, and so on. Now we actually see the pattern here. See the pattern. A, this is actually A plus 1 minus 1 times d. You will get 0d, therefore we only have A for the first term. And this one is A plus 2 minus 1 d, and this is A plus 3 minus 1 d, and the last one here is A plus 4 minus 1 d. Now we actually see the pattern, right? If this is T1, 1 minus 1 times d. If this is T2, 2 minus 1 times d. So if this is T4, 4 minus 1 times d. So Tn, A plus, this is n, so n minus 1 times d. Okay, this is the way how we derive the formula for the n term for an arithmetic progression. Now let's look at part B. On the net, the 31st purple color triangle is the last triangle with the area of 72 square centimeters, and it is given that A is equal to 30d. Okay, we want to find the value of d. Okay, this is, let's say this is a this is a last right this is a last right angle triangle with the area of 72 square meters. Now given by the questions here, we have 31st is the last one, so it means T31 is the last one, right? It's a length for the last triangle. It's a base length. Okay, how do we find the T31? Just use the formula that we relied just now. A is 30d, A plus n minus 1. N minus 1 will be 31 minus 1 d. Okay, this is 30d plus this is also 30d, and we have 60d. Okay, so it means that the length here is 60d. This is 60d. Now this is given by the question, which is 12 centimeter. Can we get the d? It should be no problem, right? How do we get the area of a triangle? 1 over 2 times the base length times the height is equal to the area of the triangle, which is 72. Okay, this one you can simplify. 30 times 12, you will get 360d. Okay, d is equal to 72 divided by 360. Okay, d is equal to 1 over 5. Okay, this is the answer for B1. Now let's look at this part 2. This will be a little bit hard, this one. Okay, now let's look at the question. Joe wants to send a number of rolls of paper to his friends through a courier service. Table 2 shows an information related to the parcel delivery charges. Okay, if Joe has 15 ringgit and the mass of the paper per square centimeter is this, it means that the mass okay, let me write this one first. It means that the mass of 1 square meters of the paper is this weight, 4 times 10 to the power of -5 kilogram. We want to calculate the maximum number of roll of the paper that can be sent if he only has 15 ringgit. Okay, now let me explain this one to you first. Let's say you have 15 ringgit. You have 15 ringgit. Okay, forget about this one first. Let's say you have a paper with the mass of 5 kilogram. So how do we calculate the charges? Okay, try to think. The first 2.5 kilogram is 9 ringgit. So definitely our charges will be more than 9 ringgit because this is 5 kilogram, right? So how do we get the total charge? This is actually 2.5 kilogram plus 0.5 kilogram. This is 500 gram, which is 0.5 kilogram. Okay, plus 0.5 plus 0.5. Okay, 5 times. 1, 2, 3, 4. Another one. Okay, so this is 9 ringgit, RM9. And this here will be 1, 2, 3, 4, 5. 0.5 kilogram will charge you 1 ringgit and 20 cents. So now you have 5 times of 0.5. So it will be 5 times RM 1 ringgit and 20 cents, right? So this is the total charges. But it's actually, if you calculate this way, it actually take time, right? Let's say you have 30 kilogram. So we need to write a lot of this. So we need to have a faster way to help us to get the total charges. So instead of calculating like this, we actually can calculate this way. So we know we need this 9 ringgit. Definitely, because we are 5 kilogram, right? Definitely will be more than 9 ringgit. So 9 plus, okay, plus. So this 9 ringgit is for 2.5 kilogram. I have 5 kilogram over here. So the rest will be calculated based on this rate. So I'm going to take 5 minus 2.5. Why do I want to minus 2.5? Because this 2.5 kilogram is already for 9 ringgit. This already paid for the first 2.5 kilogram. Okay, I'm going to take this minus this and then divided by 0.5. I want to know here how many 0.5 do I have. One 0.5 will cost you 1 ringgit and 20 cents. Two 0.5 will be 2 times 120 cents, and so on. Okay. Now, try to calculate this one. You should be able to get the same answer as this one. This is 9, and this is 5 times 1 ringgit and 20 cents is 6 ringgit. Total, you will get 15 ringgit. How about this one? You can press your calculator. 5 minus 2.5, which is equal to 2.5, divided by 0.5 times 1 ringgit and 20 cents plus 9 ringgit. You will still get the same answer. This one also the same, which is 15 ringgit. So now I am going to use this method to help me to get the maximum number of roll of paper that can be sent. First, I need to know that the total area of a roll of paper, because here is given 1 square centimeter will be that weight, right? So if I know the total area of the roll of the paper, then I will know 1 roll paper, the mass for a roll of the paper. Okay, now I need to find the sum of the base length for all of this, and then times 12. I will get the total area here. Okay, the given by the questions, the last triangle is 31st, right? So we know that n is equal to 31. Okay, a is equal to 30d, and just now we got d is equal to 1 over 5. 1 over 5. Now we know this is actually 6. Okay, the base length for the first triangle is 6 centimeters. Now, S31 is equal to n over 2, 2a plus n minus 1, d, the d is 1 over 5. Okay, now press your calculator. So, okay, this is 279. From here, I know that the total base length of all the triangle is 279 centimeter. Okay, let me draw it over here for you. Okay, 279 centimeters, and the height of the paper given by the question is 12 centimeter. Now, can I get the area? Can I get the area? No problem, right? So what you need to do, just take 279 times 12 centimeters. You will get 3348. Okay, let me write 3348. Okay, now we can get the mass of this roll of paper. Okay, this times this, 279 times 12 will give us this, 3348 square centimeter. 1 square meter will be that heavy. So this one we have to time 4 times 10 power negative 5, and we will get how many kilogram. Okay, just take out your calculator. This one, 279 times 12, which will be equal to this, times 4 times 10 to the power of negative 5. Okay, 0.13392. 0.13392 kilogram. This is a roll of paper. So the question is asking calculate the maximum number of roll of paper that can be sent if he has 15 ringgit. So now let me let the n be the let n be the number of roll of paper. We have n roll. So if we have n roll, one roll will be that weight. So how many roll we can send using the 15 ringgit? Okay, I'm going to use this concept to help me to form an inequality. So 9. Okay, this time this is not 5. This is one roll will be that weight. So we have n roll. So it will be 0.13392 n. Okay, minus 2.5. As I told you just now, this 2.5 is for 9 ringgit, and then divided by 0.5. We want to know how many 0.5 do we have here. 1 0.5, you will need to pay 1 ringgit and 20 cent times 1 ringgit and 20 cent. Okay, now less than or equal to 15 ringgit, because he only has 15 ringgit. Definitely the charges cannot be more than 15 ringgit, right? So now I want to find the range of n, and then the final answer will be the maximum value of n. Okay, so what I'm going to do here, 9, bring it to another side. So the rest I just copy 0.13392 n minus 2.5 over 0.5 times 1.20. Okay, don't have to put parentheses. 15 minus 9, you will get 6. 15 minus 9, you will get 6. Okay, so this I'm going to move it to other side. Zero 0.5. 6 divided by 1.2. 6 divided by 1.2, you get 5. Okay, now 0.13392 n minus 2.5 is equal to 5 times 0.5. Not equal to, sorry, less than or equal to 5 times 0.5, which is 2.5. Okay, 0.13392 n less than or equal to 2.5 plus 2.5, which is equal to 5, and we are going to get the final answer soon. This is multiply, right? Bring it to another side, become divide. 13392. 5 divided by 0.13392, which is equal to 37.34. Okay, but this is not our final answer because we want the maximum value, maximum number of row. So maximum number of row is equal to 37 row. Okay, this is the final answer for this question. Okay, now let's look at another question. This is also from SPM 2022. This is paper 2, section A, question 4. Show that the common ratio R of the progression is this. In a geometric progression, the sum of the first 4 terms, this is S4, is 16 times the sum of the next 4 terms. So the next 4 terms will be S8 minus S4. Can you understand why like this? Okay, let me explain this way. T1, T2, T3, T4, T5, T6, T7, and T8. Okay, the sum of the first 4 terms will be this here. It's 16 times of the sum of the next 4 terms. This. So how do I get the sum here? I take S8 from here until here minus S4. So I will get the sum of these 4 terms, right? So now I'm going to form an equation using the given information here. So the sum of the first 4 terms is 16 times of this. Okay, so what I'm going to do, I'm going to do expansion. S4 is equal to 16 times S8. If you worry that you are confused, you can put a parenthesis over here. Minus 16 times S4. Okay, so I'm going to bring this over here. S4 plus 17 times of 16, not 17, 16. Now you just assume that the S4 is X, S8 is Y. So this is X minus, this is X, this is negative, minus 16X, bring another side, become plus 16X. Okay, this is 16 times S8. Okay, here you will get 17 S4, 16 S8. Okay, so what I'm going to do now, I bring the 16 over here and S4 over here. 17 divided by 16 is equal to S8 divided by S4. Now, I'm going to do S8, sum to the 8th term and sum to the 4th term on the other side. Later on, only I bring inside this into this equation. So S8. This is a GP, so we have to use a formula for GP. A 1 minus Rn. We don't know the R. We want to show that the R is equal to 1 over 2. Rn over, oh, okay, sorry. The N is, we know this is 8. This is 8. Okay, let me double check again. A times 1 minus Rn, okay. 1 minus R. This is for sum to the 8th term. So how about sum to the 4th term? This is a same thing. 1 minus r to the power of 4. 1 minus r. Okay, what I'm going to do now, I'm going to bring these two things inside here. So 17 divided by 16 is equal to this, which is this. Over this whole thing. But if I write like this, it will it's look very confusing, right? So I'm going to change it to this. This is divide, so we can change it become multiply, and we flip over the numerator and denominator. Okay, this one look nicer. So we can start to simplify them. This is 1 minus r cancel, and this a cancel. So eventually we only have this 1 minus r power 8 over 1 minus r power 4. Okay, how to continue doing it? So this one, 1 minus r power 8, I actually can change it become 1 minus r power 4 power 2. Okay, and this is 1 minus r power 4. I only change the way of writing the r power 8. I do not change values. This one still r power 8. But why do I want to do so? Okay, because I want to use this formula. A squared minus b squared is equal to a plus b times a minus b, right? So later on I can simplify with the 1 minus r power 4. Okay, so this one, you can just add square to it. 1 square is the same thing as 1. We do not change value. Remember, you cannot change value. I just change the way of writing it. I do not change value. So 1, I write 1 square, but still 1, right? So r power 8, I write r power 4 square, still the same, r power 8, right? Now you see a square minus b square. We can use this formula. So it's actually equal to 1 minus r power 4 times 1 plus r power 4. And this is 1 minus r power 4. 17 over 16. Now these two can be simplified. Okay, 1 minus r power 4 is equal to 17 divided by 16. So r power 4 is equal to 17. 17 over 16 minus 1. You will get 1 over 16. So r will be equal to 4th root of 1 over 16. Just press your calculator. You will get 1 over 2. Okay, shown. Now, let's go to part B. Okay, now let's look at part B. It's given that the difference between the 4th term, this is T4, and the 8th term, T8, of the progression is 120. We want to find the first term of the progression. In my opinion, the question actually should tell you that the first term is positive or negative. I will explain to you later why do I say so. Now, if you do it this way, T8 minus T4 is equal to 120. Now, if we start this way, so how do we get T8? This is a GP, right? This is a GP. So we have to use a formula for GP. A times R power n minus 1, which is 8 minus 1. Ratio power, okay, A times R ratio power of n minus 1. So remember this formula? A R n minus 1. Okay, you are using this formula now. So here do the same thing. A R n minus 1, 4 minus 1 is equal to 120. So this will give us 7, and this is 3. So okay, this one you just press your calculator. 1, 2. Okay, this is 1 over 128a. How about this one? 1 over 8a is equal to 120. So just press your calculator. 1 over 128 minus 1 over 8. you will get negative 15 over 128a is equal to 120, and a is equal to 120 divided by this. You will get negative 1024. Okay, this is the answer for B1. Okay, just now I told you that actually the questions should tell you, I think, in my opinion, I think the questions should tell you that the A is positive or negative, because some students might do it this way, T4 minus T8, right? Because we don't know the A is positive or negative, so that we don't know which one is larger. Maybe T4 is larger than T8, right? If the question talking about difference, we will take the larger number minus a smaller number, right? So in this situation, the A is negative, so T8 will be greater than T4. But in another situation, let's say the A is positive, T4 will be larger. Okay, let me show you the Excel file that I generated just now. This is what we are doing here. This is T8, this is T4. So the A is negative, right? So when you multiply by 1 over 2, it become, this one is actually become larger. So you take negative 8, this is larger, this is smaller. Negative 8 minus negative 128, you will get 120. But in this situation, it's correct as also. So in this situation, this is positive, so it becomes, when you times 1 over 2, it becomes smaller and smaller. So in this situation, T4 is actually greater than T8. So you take this one, minus this one, you will still get the same thing, which is given by the question 120. So if you do it this way, if you do it another way, T8 minus T4, you will get the A, which is negative, this one. If you do it another way, T4 minus T8, you will get a positive A, which is 1024. So I think, in my opinion, the question should tell you that the A is positive or negative, so that we don't have this argument. Okay, I will just go with this one. Now let's go to B2. The sum to infinity of the progression. So sum to infinity, the formula still remember, A over 1 minus R. Sum to infinity. Okay, since the A is negative 1024, 1 minus R, R is equal to 1 over 2. Now you just plug in all the value you have here into this formula and press your calculator. Negative 1024 divided by 1 minus 1 over 2, which is 0.5. Okay, the answer is negative 2048. Okay, that's all for this video. See you in the next video. Bye bye.